Hi, Matthew here. I'm going to talk you through this Leaving Cert Maths question. It's challenging, but hopefully with my help, you'll be able to understand and answer the question. So let's get started. Question 7, which is a 50-mark question on area and volume, financial maths and a small bit of calculus. So we're told in question 7, part A, that a company decides to manufacture a drinks can with a capacity of 600 millilitres. Now capacity is just another word for volume. So the company plans to make the can cylindrical with radius r centimetres and height h centimetres. So the company plans to make the can in the shape of a cylinder with radius r centimetres and height h centimetres. So question 7A part 1 is worth 5 marks. So it wants us to find the height h in terms of the radius r. So basically it's going to be h equal to everything else. So we know that the can is in the shape of a cylinder and it has volume of 600 millilitres. So now we're going to use the formula for the volume of a cylinder to help us write the height in terms of the radius. So the formula for the volume of a cylinder is on page 10 of the formula and tables book, and it's the second formula down. So v is equal to pi r squared h. So we're going to use this now to write h in terms of r. So the formula is v is equal to pi r squared h. We know that v is equal to 600. We don't have r or h. As I said, I want to have h by itself, so I'm going to divide both sides by pi r squared. So 600 divided by pi r squared is just 600 over pi r squared, and then pi r squared h divided by pi r squared is just going to be h. So there we've written the height in terms of r, and that's h is equal to 600 over pi r squared. So that's our answer for A part 1, and now we're going to look at A part 2, and this is also worth 5 marks. So here we have to prove that the total external surface area, s centimetres squared, of the can is given by s is equal to 2 pi r squared plus 1200 over r. Just watch out here that it's the total external surface area. So the formula in the formula tables book for the surface area of a cylinder is just for the curved surface area. So we're going to have to add on to that the area of the top of the can and the bottom of the can. So basically the total surface area is going to be equal to the top of the can plus the base of the can plus the curved surface area of the cylinder. So the top and the bottom are both circles, and then the curved surface area is obviously a cylinder. So now we're going to look at our formula tables book for the surface area of a cylinder. We're going to add with that 2 times the surface area for a circle, as there's 2 circles. So the curved surface area of a cylinder is given by the first formula there. So it's A is equal to 2 pi r h, and it's on the same page as the formula for the volume of a cylinder. So we're going to add with that 2 times the formula for the area of a circle, and this is on page 8. So it's the very last formula on the page, pi r squared. So we're going to multiply this by 2 as we have the top and the bottom, and then add it on to the formula for the curved surface area of a cylinder. So as we saw there, the circle is equal to pi r squared, and we have 2 of them. So pi r squared plus pi r squared, and then plus the formula for the surface area of a cylinder, which is given by 2 pi r h. And now we can rewrite this. So the surface area is going to be equal to 2 pi r squared. And remember, in A part 1, we worked out that h is equal to 600 over pi r squared. So that means we can put in 600 over pi r squared for h. That's going to give us plus 2 pi r times by 600 over pi r squared. Now here, the pi will cancel with the pi, and the r here will cancel with one of the r's, so we're going to be left then with the surface area is equal to 2 pi r squared plus 2 times 600 over r, which means that the surface area s is equal to 2 pi r squared plus 1200 over r. And there we've proven that the total external surface area, s centimetres squared, can be given by 2 pi r squared plus 1200 over r. And that's our answer for A part 2 of the question. And now we're going to move on to A part 3, and this is worth 15 marks. So this tells us that r can vary, and it's asking us to find the length of the radius of the can, which has minimum surface area. We have to give our answer correct to 2 decimal places. So to find the minimum value of something, you're just going to differentiate it and then put it equal to 0 and then solve for the variable. So in this case here, we're going to find ds dr. Then we're going to put that equal to 0, as that's when the value of the surface area will be at a minimum. So we know that s is equal to 2 pi r squared plus 1200 over r. I'm going to rewrite that slightly as 2 pi r squared plus 1200 times by r to the power of minus 1. So now I can differentiate this. So remember, when we're differentiating something, if we have a term x to the power of n, this is going to go to n times by x to the power of n minus 1. So we're differentiating with respect to r here, so that means that ds dr will be equal to 2 times by 2 pi, which is 4 pi, times by r to the power of n minus 1, so n is 2, so 2 minus 1 is just 1, so that's going to give us 4 pi r, and then we have 1200 r to the power of minus 1, so it's going to be minus 1 by 1200 r, which is going to give us minus 1200 r, and then r to the power of n minus 1, so n is minus 1, and minus 1 is minus 2. And I'm going to rewrite that as 4 pi r minus 1200 over r squared. Now, to find the minimum point, we're going to put this equal to 0 and then solve for r. So I want to get rid of the fraction, so I'm going to multiply the entire equation by r squared. As to get rid of the fraction, you just multiply by the lowest common denominator of the denominators, and obviously there's only one denominator here, and that's r squared, so we're going to multiply by r squared. So 4 pi r by r squared is going to be 4 pi r cubed, and then 1200 over r squared by r squared is going to be 1200, so then we get minus 1200 is equal to 0. And now we can solve for r, so I'm going to plus 1200 on both sides to give me 4 pi r cubed is equal to 1200, and then I'm going to divide both sides by 4 pi. So then I get r cubed is equal to 300 over pi. So then to find r, I'm going to get the cubed root of 300 over pi. And then to work this out, we can pop this in the calculator. So it's the cubed root of 300 over pi. And the answer for that is 4.570781497. So we're going to keep that as 4.57 centimeters, and that's equal to r when the surface area is at a minimum. So that's our answer for A part 3, and now we're going to move on to part B of the question. So part B tells us that a company predicts a yearly profit of 120,000 for the year ending December 31st, 2022, and that the yearly profit will then rise every year by 5%. So B part 1 of the question is worth 5 marks and wants us to show that the predicted profit for 2024 is 132,300 euro. Now this is the financial maths part of question 7. So we know that in 2022 the profit was 120,000. So in 2023 the profit will be 5% greater than that. So we're going to multiply 120,000 by 1.05 or 105%. It's the same thing. And 120,000 by 1.05 will give me 126,000. So that's how much profit we had at the end of 2023. And now at the end of 2024, we're going to multiply our answer there from 2023 by 1.05 again. So that's 126,000 by 1.05. And this will give us 132,300 euro. And that's the predicted profit for 2024 as the question wanted us to show. So now we can move on to B part 2. And this again is worth 5 marks. So this wants us to find the first year in which the profit will exceed 200,000 euro. Now I did use a longer way of doing it from B part 1. However, we do also have a quick formula for doing this, and this is in your formula and tables book. So on page 30 you'll find the formula for compound interest. Now here it isn't compound interest, it's compound profit. However, the formula will be the exact same, except I will just represent the rate of profit rather than the rate of interest. That's the very first formula on the page. So then F is the amount that we have at the end, and then P is the amount that we had at the start, and then I is obviously the rate of profit as I said, and then T is the time. So let's use this formula now to work out when the profit will exceed 200,000 euro. So the final value, we want to see when that's going to be equal to 200,000 euro, and then P, which is the profit that we started with, is 120,000, and then I here is going to be the rate of profit, which in our case is 5% or 0.05, and 1 plus 0.05 is just 1.05, and then T is what we're trying to find out. So T is the variable here. So we're going to solve this now and work out T. Well, the first thing is I'm going to divide both sides by 120,000. So that'll give me 200,000 over 120,000 is equal to 1.05 T. So 200,000 divided by 120,000 is 5 over 3. So then we get 5 over 3 is equal to 1.05 to the power of T. Now be careful here, when the variable is in the exponent like it is here, you're going to have to use logs, as we have a logarithm rule, and I'm going to show you it now on page 21 of your formula and tables book. And it's the third rule in the center column of the page. So that's that when you have the log of some number to the power of another number, whatever's in the exponent can be multiplied by the log of that number, and they're both equal. So in our case here, we have 1.05 to the power of t, which means that ln of 1.05 to the power of t is equal to t times by ln 1.05. So I'm going to rewrite the right hand side as that, and then I'm also going to have to include the ln on the left hand side, as we can't just put in a log on one side. You have to do it on the same side, and it has to be the same log. So if it's ln, it has to be ln on the other side, or if it's log, it has to be log on the other side as well. So you just can't use a different one. So let's go back now and put this into our question to work out the value for t. So it's going to be ln of 5 over 3 is equal to t times by ln of 1.05. So let's work out ln of 5 over 3 now, and that's 0.5108256238. So we're going to write that down. So now we have to work out what the right hand side is. So that's t times by ln 1.05. So let's work out what ln of 1.05 is now. So that's 0.04879016417. So then the right hand side is t times by 0.04879016417. So now dividing both sides by the 0.04879016417, we get t on the right hand side. And let's use a calculator now to work out what we get on the left hand side. So we get 10.46984843 correct to 2 decimal places, that's just 10.47, which means after almost 10.5 years the profit will exceed €200,000. So if we're starting at 2022, 10 and a bit years after that will be in 2033. So therefore the profit will exceed €200,000 in 2033. So that's your answer for B part 2 of the question, and now we're going to have a look at B part 3. So B part 3 is worth 10 marks, and we have to find the total predicted profit for the years 2022 to 2035 inclusive, assuming that the profits continue to grow at 5% annually. So this was how we would work it out. It's going to be 120,000 plus 120,000 times by 1.05 plus 120,000 by 1.05 squared, and then all the way up to plus 120,000 times by 1.05 to the power of 13. So be careful there about what the final power is. So it's 13, as the first one here is going to be year 1, then year 2, then year 3, and there's technically 14 times the profit will be counted, as both 2022 and 2035 are included. So that means that the final power will be 14 minus 1, so 13, as in the first year the profit is already given and we don't have to multiply it by anything. So then the final one then is year 14. So now you may notice that this is a geometric series. To find the sum of the geometric series, we have a formula in our formula tables book on page 22. So let's use that now. And it's the second and last formula on the page. So S of n is equal to a times by 1 minus or to the power of n over 1 minus or, where a is the first term and or is the common ratio. So that's what you're multiplying by the first term to get the second, then by the second to get the third, and so on. And then just n is the amount of terms that you want to find. So in our case, it's going to be 14. So or a here is going to be 120,000. And then the common ratio or is going to be 1.05, as each of them is going to be multiplied by 1.05. And then n is 14, as there are 14 terms. So be careful there, it's not 13, okay? N is 14, as there's 14 terms. So now we can pop these into our formula and then evaluate to find out what the total predicted profit for the years 2022 to 2035 will be. So it's a 120,000 times by 1 minus or, so that's 1 minus 1.05. to the power of n, so that's to the power of 14. All of that over 1 minus or again, so that's 1 minus 1.05. So now we can pop this into our calculator. So putting that in the calculator, we get 2,351,835.839, and correct to the nearest euro, that's going to be 2,351,836 euro. So that's the total profit for the years 2022 to 2035. So now we're going to move on to the final part of the question, which is B part 4, and this is worth 5 marks. So it asks us to find the average profit made between the years 2028 and 2032, assuming the profits continue to grow at 5% annually. So to find the average of something, we can either add up all the values and then divide by the total amount of values, or we can integrate over the range using this particular formula, 1 over b minus a, and then the integral from a to b of the function. So our formula or function to work out the profits is given by 120,000 times by 1.05 to the power of t. So that's the fx dx part, but we also have to find out the boundary of the integral, so b and a basically. So it's going from the years 2028 to 2032. Now don't get mixed up here, we're not integrating from 2028 to 2032, we're going to be integrating from 6 to 10, as 2028 is 6 years after the original profit was given in 2022, and then b is equal to 2032 minus 2022, which will be equal to 10. So that's going to be 1 over 10 minus 6 times by the integral that goes from 6 to 10 of 120,000 times by 1.05 to the power of t dt. So we're integrating with respect to t. Now in the marking scheme, you'll see n instead of t and then dn. Both of these are the exact same, and you get the same answer either way. So 1 over 10 minus 6 is obviously 1 over 4, and the 120,000 is a constant, so we can bring that outside the integral, and then we're going to integrate from 6 to 10 of 1.05 to the power of t dt. And now let's look at our formula and tables book on page 26 to find out how to integrate a term when it has the variable in the exponent. So we're looking at this formula here. So a to the power of x, so in our case here that's 1.05 to the power of t. That's going to go to the constant a to the power of x still over ln of the constant. So in our case here it's going to be 1.05 to the power of t divided by ln of 1.05. So that gives us 1.05 to the power of t divided by ln of 1.05. And remember, this has to be evaluated from 6 to 10. And outside of that, it's going to be a fourth of 120,000, which is 30,000. So now I have to pop in 10 for t and 6 for t and take these away from each other, then multiply my answer by 30,000. So then 1.05 to the power of 10 divided by ln of 1.05 is 33.385717, and taken away from that is 1.05 to the power of 6 over ln of 1.05, which is equal to 27.466512. So now 33.385717 minus 27.466512 is equal to 5.919204775, and multiplying this by 30,000 we get 177,576.15, but correct to the nearest euro, that's 177,576 euro. And that's our answer for B part 4, the final part of the question and the end of the video. So thank you very much for watching, and I hope I helped.